Equation of a particle in simple harmonic motion is x is equal to 5 sine pi t plus pi by 3, where the quantities are in SI unit. Write down the amplitude, time period and maximum speed. Also find the velocity at t is equal to 1 second. The equation for displacement of a particle in simple harmonic motion is x is equal to a sine omega t plus 5. In the given problem, x is equal to 5 sine pi t plus pi by 3. So both are equations for displacement x. Then we can compare the two equations. A equal to 5, that is amplitude A is equal to 5 meter. Next, in the place of omega we have pi here. So omega is equal to pi. Omega is 2 pi by t. So we get t equal to 2 seconds. The initial phase phi is pi by 3. So phi is equal to pi by 3. Next we have to find the maximum speed. The equation for velocity v is equal to a into root of omega square minus x square. Velocity is maximum at x is equal to 0. So in this equation we can put x is equal to 0. Now v is maximum. So v maximum equal to a into root of omega square minus 0 square, that is equal to a omega. On substituting the value of a and omega, a is 5 and omega is pi. So 5 into pi equal to 5 pi meter per second. The value of x equal to a sine omega t plus 5. Velocity v is equal to dx by dt, that is a omega, and differentiating sine omega t plus 5, we get omega into cos omega t plus 5. On substituting the values, instead of a we have 5, and next omega is pi, and for cos omega t again we have omega is pi and t is given as 1 second plus pi by 3 is equal to 5 pi cos 4 pi by 3 equal to 5 pi into the value of cos 4 pi by 3 is minus half. So the velocity is equal to minus 5 pi by 2. The velocity at time t is equal to 1 second is v is equal to minus 5 pi by 2. A particle executes simple harmonic motion at t is equal to 0. The position of the particle is at x is equal to a by 2 and it moves along the positive x direction. Find phi if the equation is written as x is equal to a sine omega t plus phi. Given at t equal to 0, the position of the particle is at x is equal to a by 2. So at t is equal to 0, x is equal to a by 2. We can substitute these values in the equation for x. Instead of x, we can put a by 2, and for t 0, omega into 0 is 0. We can cancel a from the left hand side and right hand side. Now we get half is equal to sine phi. To get sine phi is equal to half, phi can be either pi by 6 or 5 pi by 6. So the two values for which phi is equal to half when it is between 0 and 180. Now x is equal to a sine omega t plus phi. Velocity v is obtained by differentiating this equation. On differentiation, that is dx by dt equal to d of a sine omega t plus phi by dt. We get a omega, and for sine omega t plus phi, on differentiation we get cos omega t plus phi. So this is the value for velocity. Now we can substitute the above two cases for phi. When phi is pi by 6, x is equal to a sine pi by 6 since t is equal to 0, and v is equal to a omega cos phi. Again t is equal to 0 here. We get v is equal to a omega into root 3 by 2. That is, v is positive. When we put phi is equal to 5 pi by 6, x is equal to a sine 5 pi by 6 when t is equal to 0, and v equal to a omega cos 5 pi by 6. Here also t is equal to 0. So v is equal to a omega cos 5 pi by 6. The value of cos 5 pi by 6 is minus root 3 by 2. It is a negative value. In the given problem, the particle is moving along the positive x direction. So v should be positive. So phi is equal to pi by 6. That is the first case.